The sources of methane emission can be very different. The source, which is in our interest, is methane from coal mine industry. About 70% of total amount of methane which is released during coal mine exploitation escapes into the atmosphere as a VAM, negatively affecting the environment. It's worth mentioning that the level of this emission is about 23.8 megatons per year and keeps increasing year by year. The VAM emission by coal mine industry is a serious problem, but it's also a valuable energy carrier. It's a mixture of methane and air, the flow rate of which from a single shaft is very large. Although methane concentration in VAM is usually below 1%, such lean mixture can be considered as an alternative fuel for energy production by applying modern combustion technologies such as VAMOXID. The main unit of VAMOXID is a thermal flow reversal reactor, which consists of two parts, section 1 and section 2, connected by a duct at the top. Part of the hot gas can be withdrawn from this duct to the heat recovery exchanger. Both sections are packed with ceramic monolith blocks. The valves responsible for the gas flow reversal are located close to the bottom part of the reactor. Electric heaters mounted on the top of TFRR are used only for preheating the monoliths to enable launching of TFRR before normal operation. Temperature profiles measured in reactor bed during experiments revealed that the reactor works symmetrically from both withdrawal and withdrawal gas options. The selected average parameters of VAMOXID presented in the table show that installation can work autothermally for very low concentrations with quite good conversion. Moreover, a reasonable heat recovery is already possible for methane concentration of 0.4 volumetric% or higher, which bodes well for the future in industrial installation. The expected heat recovery for an average ventilation shaft can even achieve 36.7 megathermal watts for 1 methane concentration. The recovered heat can be successfully applied for further use as a coal generation or an electricity production. Extensive experimental records were used to verify the suitability of the developed aerodynamic reactor model for optimization of the flow resistance and flow rates for design future reactor on larger industrial scale. This way minimizing the cost of energy used for gas pumping through such an installation. The original elements of the method and device have patent protection in Australia, China, Ukraine, Poland and the USA, which depending on the nation version contains 15 to 20 claims, giving advantages over similar devices of competition. VAMOXID was acknowledged and received several awards. We are looking for a partner in further technology development. The Institute and Catalysator are prepared to build VAMOXID installation with a capacity of several tens of thousands of cubic meters per hour. In case of any questions, don't hesitate to contact us.